Hello, people. My name is Chainuru. I'm a senior infrastructure engineer in the Orange County area. Today, the topic I want to present to you about is optimizing hybrid object-based storage for scalability, performance, and cost across on-premises and cloud environment. Advent of social media and advancements in healthcare and financial industry, there has been a massive increase in unstructured data like videos, images, IoT sensor data, which led to a need for scalable and cost-effective storage solution. This presentation explores how object-based storage architecture seamlessly integrate on-premises infrastructure with cloud environments and to optimize enterprise data management addresses critical challenges faced today by IT industry. We will go through the various implementation strategies, cost advantages, and performance improvements to help you develop an effective strategy for your organization. Organizations today face an unprecedented challenge in managing the exponential data growth. The object-based storage can handle large volumes of unstructured data more efficiently than a traditional file or block storage. Organizations facing exponential data growth in global data footprint by 2025. So, organizations must embrace an innovative storage solutions that balance performance, cost, and compliance regulatory requirements. Hybrid object-based storage has emerged as a critical foundation for enterprises seeking competitive advantage in data-driven economy, saving about 40% of annual operational and maintenance cost. Let's talk about hybrid architecture of the hybrid object-based storage. Hybrid object-based storage architecture establishes a cohesive ecosystem where data can reside on premises or in multiple clouds while presenting a single unified strategy while providing a single unified storage repository for all the applications. This architecture implements industry standard APIs and protocols, ensuring seamless interoperability and consistent data access methods across local infrastructure and cloud environments. To talk about the architecture typically consists of four layers: a management layer, an application layer, orchestration layer, and storage. So coming to the management layer, the management layer basically consists of, it's a software front-end interface, helps us access the entire infrastructure. And the application layer is nothing but user-facing services and APIs connecting backend storage and cloud. In the orchestration layer, the orchestration layer functions as the core of the system, making data placement decisions based on the analysis of data access patterns, performance requirements, and cost parameters. It continuously evaluates and automatically migrates data between appropriate storage tiers, optimizing both performance and cost without any manual intervention. The storage layer is nothing but a physical backend integrated hybrid storage. Let's talk more about orchestration. Let's talk more about the orchestration or data tiering architecture. The intelligent tiering engine continuously analyzes metadata and the access patterns and business policies to automatically orchestrate data placement across performance tiers. This zero-touch optimization ensures each data set resides on most economically efficient storage layer while maintaining compliance requirements and performance service level agreements. Data tier can broadly be classified into four tiers: hot tier, cold tier, warmer tier, and archive tier. And hot tier is nothing but mission critical workloads with high sensitive latency requirements and maximum throughput. We can leverage on-prem storage platforms which has flash or high performance SSD drives in it. Coming to the warmer tier, the data that is not frequently accessed, but it is quite important enough to maintain for future use. Cold tier is nothing but data that can be stored in cloud, like historical data sets, reporting data, things like that. And in the archive tier, it's comes to the data protection suite, where data that requires an infinite or long-term retentions to encompass companies' regulatory requirements. Best use case examples are healthcare and financial sectors, where they got to maintain longer retentions. Here are some of the strategies to achieve cost optimization. By analyzing data lifecycle, identifying data access patterns, use tier storage solutions to store data based on its frequency of access. Hot data on high performance, like or expensive storage, and cold data on cost effective slower storage. Implementing tiering policies, automating a data movement across performance and slower storage, continuously monitoring and analyzing the performance metrics and refine data placement strategies, and optimizing cloud resources, strategically select appropriate storage tiers and geographical regions. Based upon the organization location, you can choose the local availability zones or something far from your organization, which could be most cost effective option. So organizations implementing these strategies or hybrid object storage solutions consistently has achieved about 30% or greater reductions in their total cloud storage expenditures through sophisticated tiering strategies. So by conducting comprehensive analysis of data access patterns and regulatory requirements, IT departments can establish automated governance policies that dynamically position data in the most cost-effective location without requiring any manual intervention. On-premises infrastructure investments can also be maximized by this strategy by allocating high-performance capacity exclusively to latency-sensitive workloads, while simultaneously leveraging cloud economics for substantial majority of enterprise data that doesn't demand a sub-millisecond response times or consistent IOPS performance. Hybrid object storage architecture meets industry's regulatory compliance and data sovereignty with an unified API layer. With 75% up to 75% of the global organizations are now navigating multiple overlapping regulatory frameworks, hybrid storage architectures deliver the essential flexibility needed to address complex challenges. Forward-thinking enterprises can securely maintain sensitive workload on premises while simultaneously leveraging cloud economics to optimize costs for less regulated information assets. So with this unified API layer, we can maintain data sovereignty, retention policies, encryption, and audit trails. Implementation best practices. It is always recommended to implement these solutions, these hybrid-based solutions or hybrid storage solutions or any solutions with industry standard best practices. By any successful hybrid storage implementation approach, organizations should start with non-critical workloads to refine their approach as they go before migrating more sensitive applications. To begin with, you start with an initial infrastructure or environment assessment by evaluating the existing infrastructure, data access patterns, and getting to know the compliance requirements of that particular organization, and identify performance sensitive workloads and data that could benefit from tiering. Also, to document, it's always best practice to document all these regulatory constraints and the infrastructure information that will further influence the architecture decisions. Coming to the architecture design, it's better to develop a blueprint for integration between on-premises and cloud resources. Selecting the appropriate storage technologies for each tier and defining the API integration points and establishing the performance baselines and expectations. Policy development is key in create automated data tiering policies based upon the access patterns and business, defining the governance frameworks for consistent management across the environments and documenting all the security controls and compliance measures. Implementing and testing, so deploying integration components and validate performance against the benchmarks. So testing a failover scenario and data recovery process, and also defining RPO, RTO, recovery point objective, recovery time objective, and verify the policy enforcement and audit capabilities are met across the environment, and also testing the RPO testing the defined RPO and RTO are being achieved with this solution, with the implemented solution. Let's go through a case study where the financial organization was having a challenge, and where they had 5 petabytes of data increase, has been increasing, and their existing infrastructure could not be scaled due to financial constraints by the way the global economy is tumbling. To meet the growing analytics and the workloads, while strict regulations required certain data to remain on premises. The solution that they chose was the firm implemented a hybrid-based storage architecture with high-performance flash disks on premises for active trading data and other customer records, and all their unstructured data, integrated that with the cloud storage for historical analysis and long-term retention to meet the regulatory requirements. So they also adopted an intelligent tiering algorithm which automatically moves data based on access pattern, while a unified interface provided consistent policy enforcement across all storage locations. So the result was reduced storage cost by about 30% in the first year, and improved the performance by about 35%. And they yet achieved 99.9 in compliance requirements that was being set to their organization. And also they have decreased the storage management overhead by about 40%, and accelerated new application deployments by 60%. So when their organization had to invest less on implementing the storage implementation and their storage operational costs, they focused and they leveraged that financial budget towards deploying new applications, which helps their organization big time. So let's talk about future trends in the hybrid storage. So the hybrid storage landscape continues to evolve rapidly, with the emerging technologies enabling more intelligent and seamless integration between different environments. So organizations should prepare for these advancements by building a flexible architectures that can adapt to future innovations. So industry analysts predict that by end of 2025, more than 70% of the enterprise data will be managed through unified hybrid storage platforms that dynamically optimize placement based on real-time data placement based on the real-time analysis of workload requirements. Key takeaway from this presentation are to assess your current environment before you implement the solution, and developing a solid tiering strategy which plays a crucial role, and also implementing a unified management solution by deploying a robust orchestration tools that provide comprehensive visibility and control across your entire storage ecosystem, and prioritizing the APIs, implementing the standard industry adapted APIs and interfaces to ensure any frictionless operations regardless of data location and storage medium. And finally, defining a clear success metrics, monitoring of the performance and cost efficiency, and making sure regulatory compliance are met. Leveraging these analytics to continuously refine your hybrid storage architecture and ensuring alignment with evolving business objectives. So hybrid object-based storage delivers a transformative advantages for organizations confronting exponential data growth challenges. Through the strategic implementation of these solutions, IT teams can provide superior performance, unlimited scalability, robust compliance capabilities, while significantly optimizing cost across the entire data lifecycle. This ends my talk and the presentation. Thank you so much for listening to me. Thanks for your time.